let's wonder why. And in the meantime, I'm just going to show you that situation, how it works on the other network. Yeah, so this is the case. If you say that the solution is always a reboot, then I'm not sure about that. Okay, but sometimes, of course, it helps, and that's definitely the case. Okay, so let's see. So I got this particular machine, yes, and in order to perform that particular pasty hash, we just need to be running over here a certain tool, and I've got it already. So we're just going to move it with this particular case quickly. Yeah? Yes, yeah, PSExec absolutely does. It should be all good on my side, but let's see. Yeah, CQURE LSA. Log, and then it's a PTH, of course, and then user administrator very quickly, and then domain, localhost, and then NTLM, and then we're going to bring it on. So here we go. And then let's try here. I'm curious. So it's going to be psexec 10.10.10 200 cmd.exe, and that local administrator should be able to log on over here, yes, within this particular case. On the other hand, what is the story is that this is the moment, of course, to discuss this deny access to this computer from the network. If here we added a local administrator, yes, then at some point we will not be able, of course, to log on like this. Yes, so this is also one of the ways to prevent passy hash. Yes, for some, it says that default admin share is enabled on. It is actually enabled. So this is quite interesting scenario. Yep, let's see why is that. Okay, so whenever we are moving forward, what kind of other things do we have over here? Then, of course, within the credentials area, let's summarize the whole situation. Yes, I'm going to try one more time after starting one service in this case, and that is a little bit better. Okay. Actually, I had firewall turned off, and then I just had to turn off because for some reason the service was just stopped. Okay, so problem solved. So this was our problem. Okay, guys, so over here we can spot host name, and then we can see that we are on the web server. Yeah. Now this is of course passy hash. We can do plenty of things over here. We can perform the memory dump. We can create ourselves a user account and so on. If we check who am I, we are local administrator on the web server. So this is kind of the situation that we are dealing with. Now, how to prevent that? First of all, let's make a little bit of a summary. What can we do to prevent that kind of situation to happen? Well, I'm going to use Notepad for that. First, I would say disable debug privilege, because this is something that we absolutely do not need. Yes. A second thing, and I'm just going to discuss, of course, quite an obvious things like users not being local admins, but that's kind of obvious. But let's say we are dealing with the developer. Yes. So developer needs to be a local administrator because of blah, blah, blah. Of course, we had a little discussion in our team. Is it really the case? And we concluded that not, and it was a discussion with our developer. But of course, it's a big simplification for a lot of different accesses that developers need to have. Another thing is that in this particular case, local administrators are using the same passwords. So they should have different passwords. Yes, and that's why we've got something that is called LAPS, Local Admin Password Solution. And that is an absolute prevention on the local level against passy hash. Now, within the pen tests that I'm doing, for example, right now, what is interesting is that the administrators implemented LAPS amongst the workstations, but they didn't do it amongst servers. But what if one of the users that is, for example, a potential point of entry has access to the server? Because this kind of breaches are like everywhere. User, for example, is managing SAP server or SAP applications. So that is a problem, because then with the user, we are getting there, and because user is responsible for the certain business-related server, then we are getting access to the hash, and then we are jumping further. So this is the case. Now, what about service accounts? What about service accounts authenticating using NTLM? Yes. So these are kind of situations that could be a point of entry where we are becoming an administrator, and then we are grabbing these hashes, and then we are performing pass the hash. Of course, step number 4, yes, code execution prevention. And the reason why, it's very simple, because we were able to, for example, execute Mimikatz. We were able to execute our tool, CQ hash dump, and so on. Yeah? What is also quite important is offline access protection. Why? Because this prevents from getting system, security, and of course, SAM. And that's, of course, hashes. It's not the only problem over here. Yeah, so we can get much more than that. We can affect here the machine's data protection API, but that's something that we're going to be talking about. Things over here like credential guard, and that's where we are getting to. So credential guard, it's something that absolutely prevents pass the hash, but only on the domain level, not on the local accounts. So we could be thinking, oh, great, then step number 3, so the implementation of labs could perfectly match with credential guard. Absolutely. Yes, and of course, offline access is something separate over here. So this is a very cool setup that will prevent credentials to leak or hashes to leak. Hash is a credential, yeah. So this is why I was saying a definition at the very beginning, yes. So this is a kind of a set of things to implement, but of course there is much more, yes. Stuff like virtual smart cards, stuff of course like well, code execution prevention we have already, but we've got also something that is related with using our credentials whenever we log on to the operating system. With the smart card, we are administrators, and whenever we log on with the regular password, then we are not. And this is called authentication mechanism assurance. It's not a very popular solution. Microsoft doesn't really promote it, but it's definitely worth having a look. There are better solutions than that, but why not? Yes, authentication mechanism assurance. Yeah, have a look, because it's quite a nice scenario. And on MSDN, there's a literally step-by-step guide how to implement it. Like if you just Control-C, Control-Z, literally the PowerShell script, or by changing the names, you're going to be pretty much there. So authentication mechanism assurance. But there are also a couple of other things that are quite interesting. Something that we call it LSA isolation. But you're going to find it by searching for LSA isolation. Well, that's one thing, but run as PPL. And that is quite hardcore case, because what it does, it sandboxes LSA and it prevents injecting into it anything, including the third-party stuff that is helping you to authenticate. So if you, for example, authenticate to Windows by using a specific smart card provider, this will not work out because it's not signed by Microsoft. That's why it will be just rejected. Yeah, so LSA isolation is quite drastic, but to be sincere, like how often do we use something specific? If we use, then that's not a solution for us, that's clear. But usually this kind of a smart card logon and fingerprint logon, this is handled by Windows drivers, so that kind of saves us a little bit here. Have a look, it's quite an interesting solution that prevents absolutely from injecting anything. So this is an answer for the pass the hash at that scenario. Yeah. Okay, so we've got these guys. Of course, whenever we are thinking about all the other things, yes, we could be talking about security awareness stuff and so on. Let's skip it. Let's focus on the technical stuff. Something to add definitely on the top of it. Deny local admin. Local admin, here we go. To access computer through the network. Yeah, so that is something that should be said. And this combined with labs, that is a pretty good solution. Yeah, so even though someone has the password of the other administrator on the other workstation, this person will not be able to communicate within the network. So it not even connect, not even remotely connect. But not remotely. Remotely, I mean through the network. Yes. So these are the settings that can help us over here. Good. So this is a set of the solutions. Now, question is, how does it work with the credential guard? So what's the credential guard? What's the point around it? And how we are able to mitigate, of course, the whole case related with the credential guard, how to implement it, and so on. So Credential Guard, quite recently, thanks to the feature that Microsoft implemented in Windows Server 2016 that is called Shielded VMs, allows us, thanks to the virtual TPM or TPM virtualization, to use, of course, Credential Guard within the virtual machines. And that is an uber cool case because it was a big question of the universe. Okay, it's nice that I can use it on the regular desktop, but the environment that I really have to protect, which is servers, that is something that is just not mitigated. So how does it work? What does it offer? And what's the whole idea behind it? Well, answer to that is actually quite short. And let me show you a picture, which is actually quite a famous picture because you're also going to see it in the internet. But it's a very good picture of operating system architecture. Yeah, so that's going to be like this. So here we've got something that is called virtual secure mode. So this is a new term. Now, there are three new terms that you need to know about. One thing it's called virtual secure mode, another thing it's called the isolated user mode, and another thing it's called credential guard. So these three terms are quite confusing, but I'm super happy, of course, to explain what it is and so on. So whenever we are thinking about virtual secure mode, yes, virtual secure mode in general, yeah, that is I call it a little bit of a proxy, so the layer that allows us to isolate stuff from the operating system. Or we could describe it briefly, that allows us to isolate, for example, well, sensitive and critical processes from Windows kernel. Even though it sounds maybe quite shocking, let me explain, of course, what do we mean by this. So we've got our virtual secure mode. Now, where is it? How does it work? Normally, and I'm going to enlarge a little bit, normally it works in a way that whenever here we've got some type of an application, we've got, of course, Windows kernel, and we go through the hypervisor. On the top of the hypervisor over here, we've got running different types of virtual machines. What's the difference in between the virtual machine and a process? Well, technically, virtual machine is also a process, quite specific because it has access to many different resources, but it's still a process. It's a process that can be accessed and managed through hypervisor. Now, question is, if I'm running over here a special application in this area, and I want to make a memory dump of the virtual machine, can I? Of course I can. What's the problem? Yeah, there's no problem about making a memory dump of the virtual machine. So that is actually a security problem because taking into consideration the fact that in the memory of the local security authority subsystem, we've got hashes, at least hashes, and could be as well credentials, so like passwords, then basically that shouldn't be possible, especially when we think about cloud providers. Yeah, I really don't want to have a server running on someone's server, physical server, that someone can make a memory dump to. So what is the idea standing behind VSM? So VSM is like a little bit of a proxy. Of course, it's not a proxy. I call it a proxy just to clarify the whole concept over here. But that little proxy works like this. If I have running here application that wants to perform the memory dump, then this particular application will try to contact this virtual machine, let's say. So let's have here virtual machines, so it's a little bit easier to explain, through VSM, yes, and then basically perform the memory dump. But the problem is that this is absolutely not allowed. Why not? Because VSM filters that type of a question. And that question, enlarging one more time, yes, when it's made from here, it just stops over here. And hey, I want to make a memory dump. Sorry, not allowed. Because API does not allow that. And Microsoft spent a lot of time to investigate what kind of techniques can be used in order to get into the memory. Yes, and that techniques are blocked. Yes, so we are not able to use them through and run them through hypervisor. Now, let's rephrase it a little bit. What if, for example, over here, we put a process? So don't think per virtual machine. It could be, absolutely, it could be virtual machine, but it could be also a process. Well, that would be nice, so that whenever I try to do something nasty with the critical process, that is not allowed, because that kind of activity is just forbidden. Yeah, so that is the situation. So hypervisor, it's an absolutely important part over here, because this virtual secure mode, it's actually a part of the hypervisor. But let me explain the requirements in a moment. So when we do that, when we communicate like that, that process is okay over here, because it hasn't been touched with the functions that are just dangerous. And that is exactly something, in this case, that we call an isolated user mode. And the specific case of a process, which is local security authority subsystem, specific case of a process, it is called credential guard. Why credential guard? Because it protects credentials. And that is the domain of LSAS. It could be called my super duper nice secrets guard. We don't have a feature like this in Windows if it was related with my own application. But developers can write applications like that so that they are running in an isolated user mode, so that they are communicated with through virtual secure mode that work similarly to credential guard. Yes, using these three terms in one sentence. So that kind of situation, yes, allows us to implement here virtualized, everything because software at the end, local security authority subsystem. Yeah, so this is the place where we've got an LSA or part of the LSA. Yeah, and then we've got virtual TPM. It's new, very, very cool feature, because through this virtual TPM, think about it, we can do this. We can go like this through the virtual TPM, and we can, on the top of it, build virtual machines that will implement credential guard here on the top of this. So this is clearly an inception. Yeah, so it's a virtualization in the virtualization. Yeah, so we are able to do that right now, and that is an integral part of the hypervisor. So you can run it on the regular Windows 10 client, but it needs to be an enterprise edition. That's not a very good news, I know. And of course, right now you can run it as well within the Windows Server 2016 through a virtual TPM, which I personally think it's awesome. So another case, we've got a hypervisor and code integrity implementation, so implementation of the device guard, which can also rely on that, but this is a subject for a different session. So that is how we are implementing that kind of stuff. Now, question is, and let me take this out, this is my little Rocky, how can we basically extract credentials from the virtual machine like this, yeah, that has this credential guard implemented? Absolutely, absolutely. How do we do it, of course, and where do we implement it? Well, we implement it within the group policy, and this is one of the cases. First of all, let me show you how it works, and then we're going to talk about the requirements, because requirements are not that bad, but they have to be followed. Okay, so we're going to do here secure LSA, logon passwords, enter. There we go. And what do we get over here? Well. So, as you see, yeah, over here, we've got, or we start to get over here, information about isolated user data. Ah, perfect. Have a look. So here I've got Freddy Krueger, and Freddy Krueger, it's a domain member, and his domain credentials are secured. Because normally we will see over here a password, but then it says LSA isolated data. And here we've got the data protection API, so the public key to encrypt the data into isolated user mode, but that's pretty much it. I don't even have a hash over here, nothing that I could use. So that is exactly how it works. And what can I do about that? Nothing. That's the point. Yeah, that's exactly what we want over here. But question is, what about the other stuff? Yeah, so I got over here as well another account being logged on. So assuming that you work in a small organization and you by accident used domain admin against, we could say against workstations. It's an attack on workstations, logging on with a domain admin. Over here, we've got an LSA isolated data. Yeah, so we are not able to pull out the domain admin credentials from the workstation. Yeah, so of course we shouldn't be doing this because that's not the only threat that is out there, but that is solving this single problem related with credentials being in the memory and hashes and passwords being in the memory so that we can grab them and perform pass the hash. Okay, so this is how it works. Now, the question is, what kind of little requirements do we have? Well, requirements are like that, and that is quite straightforward. Yeah? So in order to enable VSM, we need to have a secure boot. That's it. So if you have it, don't hesitate, because it's actually quite easy to implement and it just works. Yes, but you need to have a Windows 10 Enterprise. That's the case. Second thing is that machine must be connected to the domain. So if you kind of expect that solution to be for home users, absolutely not. On the other hand, where pass the hash could happen? Well, credentials could be stolen, but credentials will be stolen anyway as long as you are using local accounts. As we were mentioning, VSM, it's not for the local credentials. Yes, it's not for the local accounts. It's only for the domain ones. Now, install Hyper-V feature in Windows 10. That is actually quite clear. And we've got the entry that we need to modify a little bit. So one little thing over here, VSM launch type auto within the BCD edit. We add this on our boot entry. And at the very end, the last step, yes, the machine, the virtual secure mode, and the machine must be configured within the group policy, of course, to turn on virtualization-based security. And that is the setting that you find in the computer configuration. Yeah, so this is how we are protecting from pass the hash in the modern machines. Yes, in the modern machines. So we can do it both on the regular machines, on the regular physical clients, and also on the virtual machines finally. But you have to have Windows Server 2016 running. That is the absolute requirement over here. Okay, guys. So this is the setup. Now, question is, of course, how and what's the whole story behind this pass the something attacks? Yes, because that is also quite an interesting case. Well, I wouldn't be myself if I didn't mention this, but we will not talk to it for a long time because that will be focusing more on hacking rather than on securing, which is good too, but maybe the other day. Now, there is also an attack that is called pass the ticket, yes, which is related with the Kerberos tickets. And the keys with the pass the ticket, it's similar with the, of course, pass the hash, or similar, not the same, of course. And it allows us to extract the tickets that we've got in the computer's memory because someone from the domain logged on, and then we are able to assign this ticket to ourselves to be this person. Yes, so that's another version of this attack. It's another version of, I could say, pass the type of an attack. The same type of prevention applies over here, but additionally, of course, what would help us is the code execution prevention. Yes, let me of course show you how and what we are able to do in order to prevent this kind of attacks, and how do they work. Yeah, so that will be a little bit of a summary. Now, that situation works like this. Basically, let me show you. Every single time we are logged on as a certain type of a user, yes, in a domain, we get the domain ticket. And these tickets, as we have them, they are the ones that have been generated right now. We can see by the time. So today is the 1st of December. Yes, and we've got over here different types of ticket types. How did I display them? Just by using KList. KList, by the way, has a very nice functionality, which is called Purge. And Purge allows us to clean out those tickets from the memory. So if you are bothered by that problem and you are in a situation like, what we're going to do, we have to implement a blocker or credential guard, it's going to be in a couple of years and so on, maybe this is something that you can also take into consideration. Every single time you log off, there is a logoff script that purges your ticket. You don't need it after you are not there. Yes. So so this is the case. After you leave, you don't need it. So we can always, of course, do that. What is my point over here is that if we log off, actually I switched the user, but I have to log off. So if we log off from that particular user, let me log on again and log off so that we are fair and I show you 100% what I want to address over here. So I'm gonna use this guy and then we're gonna log him off. Sign out. Okay, we can do that. We've got in the even local account possibility to extract tickets. And that can be happening if, of course, we've got the possibility to play with the ticket. So I have to be an administrator over here. And let's check. If we've got the possibility, of course, to get the debug privilege. So again, over here, privilege, debug. And then we've got over here, secure LSA, tickets, export, punk. And this gives us a list of different types of tickets that we've got within the memory. In my case, yes, as you see, I've got over here the Kirby TGT. Yeah, so this is a ticket of who? Administrator. So I can take this ticket and I can assign it to myself in order to be able to act as this guy. Yeah, so this is the situation we're talking about. Even though, for example, I would just run this as an administrator and I'm going to do, for example, dear AWS 2012 DC CQURE.tech. Yes. It says directory syntax is incorrect. Okay. Let's. Yeah, I wonder why it's like this. Sure, maybe. Yeah, that's a little bit better. So the username or password is incorrect. Yeah, which indicates us a single sign-on. Yes, over here, if we've got a certain ticket, we can always assign it to ourselves and then perform the attack. Yeah, so Kerberos, PTT, and then we've got pass the ticket, paste tech, Kirby, yes, and then of course that particular ticket is passed. Now question is, do we have access to the stuff? And as you see, we do. I just did the arrow up, and then who am I? I'm Paula. And if I do klist, yes, I have over here tickets that are domain admins, not the regular local users. So that is what we are talking about. But of course, the same situation. Sorry, let me go there. The same situation applies over here. Yes, so we should have possibility to get the debug privilege. And as long as this is possible, then sorry, yes. Even though when we read about debug privilege, it's even in Microsoft, in the policies in written, that this is a privilege that allows to play with the critical system components. Well, then what do we expect? Yeah, so we can do pass of everything at that certain stage if we've got the debug privilege. Okay, guys, so hopefully that explains a little bit of the whole situation. Now, let's talk about something that is really cool, which is, of course, cached credentials. Oh, I love this subject, especially because this is the subject that our team is so much engaged to, because what we did, we kind of a little bit reverse engineered that case. So please, of course, as always, ask any questions that come to your head, and we will do our best to answer. Yeah, so no question will be left unanswered unless you ask for something really difficult. But then hopefully we'll be able to check that. Okay, so lovely. Let's move forward. So first of all, cache credentials. What are they? Where are they? And are they really credentials? So over here we are anti-authority system. And the reason why I'm anti-authority system, and I'm going to show this to you on Windows then, it's because cache credentials or cache logon data is stored in the security hive. So in order to be able to decrypt them, what do we need to get? System and security. Yeah, so we've got that. So when we have a look at the whole scenario, yes, at the very end, question is, of course, what we are talking about. well, first of all, if we get into security options over here, yeah, then let's have a look. Here, I've got 10 logins, yes? So this is what we are talking about. Interactive logon, number of previous logons to cache in case domain controller is not available. And then it's 10. Now, what really makes me laugh is that some people are like, oh, let's set it to 1 or let's set it to 0 and so on. Like, guys, it doesn't matter. And let me explain why. So we can set here 50. It doesn't really matter. Yes, but basically, let me get there. So these cached logon data, if we go to regedit, it's over here in security and cache. So this represents us 10 items. Why 10? Because this is what we got over here in the policy. 10. What if I change it to 11? Why not? Yeah, so, okay, perfect. Now have a look. So this is a registry. I'm going to do F5, pink, and then we've got number 11. So that represents us, just the slots. How many slots I got? So this policy, you can imagine, it's kind of funny, right? Because it's like, okay, so if I increase the number, then it just adds one more key to the registry. So why I just don't do it by myself? Yeah, okay. Let's don't comment on it. But that's exactly what it does. It just adds you one more slot. Is there something specific about that slot? No, nothing. You could create it by yourself. Okay. So let's see. First of all, we will check on one thing. In this particular computer, I am logged on as Freddy Krueger, as you see. And what is really cool is that if we get into the tools, you've got the same machine, by the way. So we've got here CQ tools. There is this Chrome pass. And this Chrome pass will show you, if you were at some point in the labs right now, if not, then you're going to see it later, that Freddy has the password #123 ! In order to log on to LinkedIn. Okay, now why is that? This is because of the data protection API. That's going to be just our next subject, just after cache logon data. Yeah. So over here, I'm able to see it because it's my password. I have encrypted it with my own hash. That's data protection API. So, question would be, if I, for example, restart this computer and I will play with the cache logon data. Will this affect my secrets? Can I get access to the computer just like that and so on? Well, yes, but let's get there in a second. I just want to show you one more thing. I'm just searching for the console that is, I think I might have closed it, running as a, oh no, this is this one, running as a local system. Here we go. Now have a look. Over here, I got 1, 2, and 3. These 3 items, yeah, these are cache logon data. So someone logged on over here. Someone logged on over here. And these are the logon types, logon items, logon information cached over here. Okay, so let's pretend that we will log on with the cache credentials, as we call them. Lovely. So in order to do it, let's simulate the full situation how it is. So I'm going to restart this box, and then I'm going to override cache logon data in the registry so that to show you that we can do it, and then I'm going to log on with it and explain in details what happened. Before we do that, one more thing that is absolutely necessary for you to see. I'm going to lock this desktop. Here we go with Freddy, and I'm logging on with password. Yeah, everybody sees that. So enter, and I'm able to log on. Okay, so this is something that I wanted to prove to you. Okay, perfect, restart. Yes, and this machine will be restarted by, here we go, from the ISO image. Tick, press any key, so I did. Lovely. Let me enlarge this window a little bit, so I'm going to close it and reopen it one more time. And within this machine, lovely, okay, this one is going to be just a simple case. Media and view and end session after we're going to reboot. Yeah, so here we go. This needs to be like that. So simple one. Next, repair your computer. And then we go to troubleshoot, advanced options, and command prompt. This is the regular Windows ISO, so not a big deal, yes? But what I have in this machine already, I have, of course, Mimikatz. Yes, we're going to be using for that too. This is quite a special edition over here. And I'm going to get into the CQ tools, of course, and then CQURE edition. CLS, we got it. Perfect. So that's what we're going to be doing at that certain stage. So Mimikatz, we're going to be overriding cache logon data. How, why, and what for? Well, because I want to prove to you that cache logon data, it's not dangerous, that's A, and B, that data protection API really depends on it, which is great. So these two things, which you will see after we change these credentials over here. So how do we do that? Well, we do LSA dump cache. That's kind of a command that we maybe need to learn. And then, in order to be able to change cache logon data in the registry that I was showing you before, we need to have access to Windows system32 config, and I'm sure you know, which is system always, then D, Windows system32 config, CQURE, lovely, and then very important switch, which is QE, which will make sure that these credentials are changed in the registry. So let's run it. Perfect. So over here, we've got an information that what was cached in a NL1 was administrator, and in NL3 was secure Freddy Krueger, and we have changed that data. Now, you might be wondering, how is it possible that I'm able to read this information? Well, let's don't forget that I've got access to the system hive at that point. So I'm able to decrypt these values, yes, these cached data, and one of those things is an information about the username. Of course, it's never a password, and that's what I would love to explain to you in a moment. So even though I can see over here MS cache v2 or checksum or whatever, that doesn't really change a thing. Okay, so we are done. But before we move forward, we have to simulate the whole situation. So user is in Hawaii on the beach, not connected to the network, and in the mood for work. So he's gonna take his laptop and boot it or whatever, and he's gonna, of course, log on to his profile. I'm not booting from the CD/DVD right now. Lovely. And we're going to be getting access to that particular box, yeah, right now. Oh, lovely. So this is my opportunity to change it a little bit. Perfect. We're going to get it a little bit bigger. And at that certain stage, well, question is, can I log on with the password? Let's have a look. So I got password, enter, and then it says, it's incorrect. Okay, so what's going to be the password then? Well, if we change it to something like this, so we've got over here Mimikatz. This is what our Kiwi switch did. Then enter. As you see, I'm logging on. So I'm not logging on to the local user. No, I'm logging on to the domain user, but by using cached logon data. Yeah, so this is the case. Now, question for us would be if I'm able, for example, to see the user's secrets. And I shouldn't be. And that is exactly the point. So we go to the Chrome pass, and that takes a little bit of time, of course, because the reason why it's like this is because we are searching for appropriate data protection API information, which this subject is to be explained in the moment, yes? And then we are not able to see the password. In a short words, to explain this situation is that we were trying to use our password, which was Mimikatz, to decrypt values, to decrypt our secrets, and we couldn't decrypt them because the password is different, and there was no legal way to change it. If we were resetting our password legally, like we're using the Windows mechanisms, then our stuff would be definitely decrypted and encrypted again. But because we were not using it securely in a legal way, then this is exactly what we've got over here. Now, I just want to, guys, remind you one little thing that we've been talking about on Monday. Yeah, that is security login type. Again, as I said, this is very important for us to to know exactly in details. Why? Have a look, because over here we've got security logon type, interactive, it's 2, network 3, 4, 5, 6, blah, blah, blah. And then we've got something that is called cache interactive, eventually cache remote interactive, but very, very important type of a logon is here. So I'm going to mark it with red, which is called new credentials. So we could be like, what does it mean? Like, but it's interactive, right? No, that's the point. It looks like interactive, it smells like interactive, but it's definitely not interactive. It's with new credentials. When you log on with new credentials, there's a lot of magic happening underneath. Or actually, we shouldn't say magic because there is nothing like magic. But what happens is that your data protection API is very much engaged in that type of logon, and it decrypts your secrets with your old password, encrypts your secrets with your new password. That's why when you change your password, you need to give your old one and you need to give your new one in that particular mechanism. So that is the situation that we are dealing with. Okay, so let's take this out and let's find out and summarize what is cache logon data, because this is a pretty interesting mechanism. Cache logon data, and I'm sorry, it's another difficult slide in this presentation, looks like this. You don't have to learn this. I just want to give you 100% of the information about the subject, yes, which is this. MSDCC2, it's a value that is stored in the registry. So this is this cache thing in the registry that you could see. This is called MSDCC2. Why like this? Because we had DCC1 before, and that DCC1 was a value that was stored in the registry in Windows XP to the bottom. Yes? So this is the case. Now, this is something that you really don't need to know in details, yes? But just know that, of course, the name of MSDCC2. Exam is one thing. Second thing, it's practice, yeah? So that you know what you are operating on. Now, let me give you a little bit more information regarding cache logon data. So, summary, yes? That stuff looks like this. So this is this value that we got in the registry. Yeah, it looks like this. It was actually starting in our case 1000, yeah? And that function that we were using looks like this. Putting this in the more practical terms, what is happening out there is that your username, it's taken when the cache logon data is calculated and being written to the registry. Your username is taken. So, for example, Freddy Krueger, your password's hash is taken. Password hash is taken, so your MD4 is taken, and username and password hash is combined in one string. And on the top of that, we calculate a hash. Yeah, on the top of that, we calculate MD4, and that is something that is called DCC1. Yeah, so what I just described is DCC1. So username, user's password hash, combined together. On the top of that, we calculate the hash. Now that blah, blah, blah hash, so MD4 of what we've been mentioning, it's an input value into this function. And we run this function, 10,240 times, charming amount, within 16 blocks. And this is the value that lands in the registry. But before it actually gets there, one last thing, it's being encrypted. Now, why and how it's being encrypted? That's why I showed you this slide. Yeah, so cache entry decrypted. So step number 7 is MSDCC2. So result of the function that I was mentioning. Yeah, so MSDCC2, it's an encrypted value of the function. So in order to decrypt them, you just need to know the algorithm, and that's it. Not a big deal. But the next thing, which is a big challenge, is of course to deal with DCC1 and MSDCC2 in total. So how and what is the way of this being cracked? And that is actually quite a simple case. This can be cracked only if you pre-generate rainbow tables that will contain MSDCC2 values. But that is at 2 dimensions. There are like 2 dimensions. So one thing is a username, second thing is a user's password, and on the top of it we got a hash. So these 2 things must match. So that rainbow table is going to be really big. So can we consider that cache logon data is safe right now if someone takes it from the registry? Absolutely. But what if someone takes it from the registry of Windows XP? Then brute force is a little bit more possible, because in Windows XP we only use DCC1, and from Windows Vista we use DCC2. Yeah, so that is something that is absolutely worth paying attention to. So long story short, what is the case over here in the whole case is that these values are of course safe. Even though someone's going to get access to, for example, your system, yes, or system hive, then yes, this person will be able to get access to our cache log on data, but what's the point? Yes, as long as, of course, you don't have a super duper big rainbow table, then you are kind of on a safe page. Yeah, so this is the case. Now, what about the other things? What about Windows XP? Well, unfortunately, in case of a Windows XP, it's not that clear. Yes, it's definitely not that clear. In Windows XP, these values